Okay, before we looked at solve by factoring when a, our coefficient of x squared, was 1, today we're going to look at the same thing, solve by factoring, when a is greater than 1. And if you remember when we were learning how to factor when a is greater than 1, you have one extra step, is that sometimes you end up with a fraction for your factor, and you have to write your binomial a little different. So let's look at these. First, and as always, you always look to see if there's a GCF, and in this case there is. It's 3. So you get x squared plus 3x minus 12 equals 0. So when we pulled out our greatest common factor, it put it back to where a equals 1. So we can do like we were doing on the previous video where a equals 1. A times c is negative 12, b is 3. And in this case, a is 1, so we're going to divide by 1. So the factors of negative 12 that add up to 3. All right, so if you think about, let's see, 12 and 1 is not going to do. 6 and 2, I can't get 3 out of that. 6 and 2, 3 and 4. Up. No wonder I can't find a factor. What did I do, y'all? Do you see? Can you see what I did wrong? Yeah, that's not negative 12, is it? I didn't divide negative 12 by 3. This ends up being negative 4. Alright, so this makes it a little easier now finding factors. The factors of, yeah, I did that on purpose for sure. You do have problems on the EOC, though, that ask you, what did they do wrong? So, there you go. That's what it was. Alright, factors of negative 4 that add up to 3. If we put 4 times negative 1, we're going to get negative 4. If I say 4 plus negative 1, then I'm going to get positive 3. So that's going to work for us. Now the 3, it is the GCF. So we're going to have x plus 4 and x minus 1. All right, so we're going to split these up and set them to 0. 3 does not equal 0, so we're not going to pay attention to that. X plus 4 equals 0. X is negative 4. X minus 1 equals 0. So x equals 1. So my solutions are negative 4 and 1. Alright, let's look at the next one here. Let's kind of go into what I was talking about earlier. First, I'll look to see if there's a GCF. Well, 2 won't go into 5, so that we're not going to have a GCF. So we're going to have to factor using A is 2, B is 3, and C is negative 5. So on my X, 2 times negative 5 is negative 10. B is 3. And instead of dividing by 1, this time A is 2. So we're going to have to take that into consideration. All right. So I'm going to look at the factors of negative 10 that add up to 3. Well, if I put 5 times negative 2, I get negative 10. And 5 plus negative 2 is positive 3. So that's going to work for us. Okay. So now I'm going to see, can I divide these evenly? Negative 2 divided by 2 is negative 1. So I've got that as a factor. And then 5 divided by 2, well, that's going to equal a fraction, right? So this is an improper fraction. So I'm going to have to deal with that. All right. So my binomials are going to be, look at the negative 1, x minus 1, Now for the fraction, if you remember, you take the denominator, put it in front of your variable, and then take your numerator with its sign and put it behind the variable. Okay? So 2x plus 5. Denominator goes in front, the numerator goes behind. Okay? All right, so now we've got these, and we're going to set them to 0. All right, this one's simple, x equals 1. This one is going to be a two-step equation. So I'm going to have to subtract 5 from both sides. So 2x equals negative 5. And then I'm going to divide by 2. So x equals negative 5 over 2. Or you could say x equals negative 2.5. All right, so that's, you've got two solutions. And yes, we can have an x-intercept or a solution at negative 2.5. All right, so if I was to sketch a graph of this, my intercepts would be negative 2.5 would be about here, and then 1 would be about here. My vertex would be the opposite of b over 2a, so 2 times 2, so negative 3/4. So it's not quite 1, so it's going to be about right here. And then that's my axis of symmetry. So if I plug in 2 times negative 3/4 squared plus 3 times 3/4 minus 5 equals 0. If I plug that in, then I'm going to get, if I plug that in, I'm going to get negative 1.625, which is the same thing as negative 13 over 8. All right, so that's your vertex. So negative, a little bit over negative 1.5 would be here. And it is positive, so it's going up. So your graph's going to look something like that. All right, these intercepts are your solutions. All right, just kind of give you a reminder what it looks like on the graph. Okay, all right, let's see, what do we want to go to? Let's look at, number 1. All right, let's see, let's go to number 3. All right, do I have a GCF? No, 13's prime, so no, we don't. All right, so for my x, a times c is negative 30, b is 13, and we divide by a, which is 3. Factors of negative 30 that add up to 13. All right, so if you think, well, you say 13, 3 and 10. Yeah, but this is negative, so that means one's got to be plus and one's got to be minus. So that's not going to work for us. How about 15 and negative 2? 15 times negative 2 is negative 30. 15 plus negative 2 is 13. So that's going to work for us. So now can I divide these? 15 divided by 3 is 5. And this one I cannot divide without getting a decimal. All right, so we're going to leave it like that. So my two binomials are going to be x plus 5, this one. And then for this one, we put the denominator in front of the variable, numerator, -2, behind it. All right, so now let's just set them to 0 and solve. Okay. So this is going to be -5. And then we got 3x equals +2, and then divide by 3, so x equals 2/3. All right, so your x-intercept is going to be at 2/3 on the x-axis and at -5 on the x-axis. So it'll look something like that. Okay. All right, let's turn your page over on your notes. And let's do number 7. We'll do 7 and 10, okay? All right, number 7. Do I have a GCF? No, 4 won't go into 5, so no, we don't. All right, 4 times A times C, 4 times -5 is -20. And we're going to be dividing by A, so divided by 4. And then B is -8. So the factors of -20 that add up to -8. Well, I would think -10 times 2 is -20. -10 plus 2 is -8. All right. Okay, so this fraction, well, it won't divide evenly, but I can reduce that fraction. And you need to reduce the fractions, okay? If you don't, it'll work out at the end. You'll have to reduce it at the end. So just go ahead and reduce it now. This one, we can reduce it to -5/2. Okay. So my two binomials are going to be 2x minus 5 and 2x plus 1. Remember, denominator goes in front, numerator goes in the back. So let's set them to 0. And then we're going to solve them by solving the equation. We're going to do the opposite, add 5 on both sides. That cancels. 2x equals 0 plus 5 is 5. And then 2 is multiplying, so we're going to divide to make that 1x. I have to divide over here. So x equals 5/2, or you could say 2.5, or 2.5. Okay. All right, on this side, we're going to subtract 1 to get rid of it. So we're left with 2x equals -1. And then since 2 is multiplying, I'm going to divide to get rid of it. I do the same thing on the other side. So 1x equals -1/2, or -0.5. Okay. All right, and let's do one more. Number 11. This one, remember, we need everything set to 0. So I need to take this 5 and make it 0. So if I add 5, that'll make it 0, right? So that means I have to add 5 on the other side as well. So we have 12x squared plus 32x plus 5 equals 0. Now, can I simplify those? No, 5 won't go into 32 or 12. So this is A, B, C. All right, so on our X, A times C is 60, and then B is 32, And then we're dividing by A, which is 12. All right? So factors of 60. Now, if you, on the EOC, if this problem was on the no calculator part, you would have to think about your factors of 60. So what I do is start off with 1. 1 times 60. 2 will go into 60 30 times. 3 will go into 60 20 times. 4 will go into 60, 15 times. 5 will go into 60 12 times. 6 will go into 60 10 times. 7 won't do it. 8 won't do it. 9 won't do it. So now we're back to 10. So this is all our factors. Okay? So of these pairs of numbers, which one of them can I add to get 32? Well, that would be this one, right? 2 times 30. All right? So let's reduce our fractions. This would be 1/6, and this would end up being 5 over 2. 6 will go into 35 times. 6 will go into 12 2 times. All right? So our binomials are going to be 6x plus 1 and 2x plus 5. So we're going to set them to 0 and solve. So 6x equals -1. So x equals -1/6. And then 2x plus 5 equals 0. 2x equals -5. And x equals -5 divided by 2, which is the same thing. If it's improper, I go ahead and make it a mixed number. So the 2 will go into 5 2 times with 1 left over. So -2.5. Okay. All right. That's all I'm going to do today. I believe you've got a practice sheet on this. All right. Y'all have a good evening.